So the problem here is that we are coloring each point of the XY plane with integer coefficients red or blue. So that means we're coloring 1, 1, 1, 2, any integer point in the XY plane. And we want to show that there is a set of 3 vertical lines and 3 horizontal lines whose 9 points of intersection all have the same color. This is a Ramsey theory coloring style problem, and here I have the definition of the generalized pigeonhole principle, which is very popular in some of the elementary Ramsey theory problems. This definition is from the book Basics of Ramsey Theory by Veselin Jungic, and it states that if n pigeons are sitting in k pigeonholes where n is strictly greater than k, then there's at least one pigeonhole with at least the ceiling of n over k pigeons. So that means the highest or the lowest integer greater than or equal to this value, and at least one pigeonhole containing not more than the floor of n divided by k. So the closest integer below or equal to this value, pigeons. Now, as a tip for a Ramsey theory problem, especially these anything that you might feel the pigeonhole principle is useful, we can identify what are our pigeons and what are our pigeonholes. In this case, the pigeons are the points, and we are trying to assign them one of 2 colors. So the holes are the colors being assigned to them. So we are going to consider a grid that is this means 65 columns and 5 rows. Why I'm picking these numbers will become clear later, but if you're not really feeling confident in your pigeonhole skills, you can pick very large numbers if you'd like. Next, we note that in a set of 5 points, which in this context refers to the rows, there will be at least this value, the ceiling of 5 over 2 with the same color. Because if we're looking at, just to show an example, we'll consider 2, 3, 4, 5. It's pretty clear that no matter how you color this, if you're doing a 2 coloring, you'll end up getting at least 3 points, which is the ceiling of 5 over 2, that are the same color. One important thing to note is if we look at all ways to color 5 points with 2 colors, we have, the way to calculate this is 2 ways to color this point, 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 2 ways to color this point. So we have 2 times 2 times 2 times 2 times 2, which equals 2 to the 5, which is 32. So we have 32 distinct ways to 2 color 5 points. Now we may recall that the grid has been defined as 1 by 65 and 1 by 5. So that's 65 columns and 5 rows. We can note now our pigeons are the 65 columns of length 5, and our pigeonholes are the 32 distinct colorings. So, following the pigeonhole principle again, there will exist 3 columns of the same 2-coloring pattern. So, what does this imply? This implies that there exist, as I said, 3 columns of the same color pattern, and within these color patterns, there will be at least 3 red or 3 blue. I have drawn an example here to give a bit of intuitive understanding. So we have just 3 arbitrary uh, colorings along the 65 columns. And we can note, if we draw a line through here, line through here, and a line through here, as well as a line through here, line through here, and a line through here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 points of intersection of identical color. So we're quickly just going to write that down formally. So we'll say if we draw 3 vertical lines through the identical color, or the identical column, and 3 horizontal lines where the specific index in the column are the same color, we have our 9 points. And we are done.